Welcome to the Scope series. Over the next 7 modules we'll go through every scope in the core palette. Async, flow and subflow, for each, parallel for each, try, until successful, and cache. A scope doesn't do work itself. It wraps a group of components and changes how they run. We start with Async, and it's the one that surprises people most, because things you change inside it do not come back out. Let's see exactly what that means. Here's a real flow. A set payload runs first, then the async scope, which contains its own set payload and set variable, and then after the scope there's a remove variable. When the message reaches the async scope, Mule does something specific. It hands the contents to a completely separate thread and immediately carries on with the main flow. It does not wait. The components inside async and the components after async are now running at the same time, on different threads. That's the whole point. The caller gets its response without waiting for the slow work inside. And notice the notes written on this screen. Payload before and var before on the outside, inside payload after and inside var after on the inside. That's the question this module answers. Click the async scope and its properties open at the bottom. There are only 2 settings, and this is important. Neither one is mandatory. Async works with both left alone. Display name is the label on the canvas, and here it's the placeholder async name here, which we'll come back to. Max concurrency is optional and limits how many events can run inside this scope at once. Leave it empty and Mule decides, but look at the error on the screen. Value must be an integer. Somebody type the words add concurrency here into that box. Max concurrency accepts a number and nothing else. If you're not setting a real limit, leave it completely empty. Don't type placeholder text into it. Now the part that matters most. Before the async scope, the payload is whatever the outer set payload created, and there are no variables. Inside the scope, the payload and variable are both set, and inside they are real. If you loaded them there, you'd see them, but after the scope, back on the main flow, the payload is unchanged and that variable does not exist. Why? Because async gets a copy of the event. It runs on its own thread with its own copy, and nothing it does travels back. This is the single most common async mistake, setting a variable inside async, and then trying to read it afterwards. It will be null, every time, and there will be no error to tell you why. Now transactions, and this is where async gets genuinely dangerous. A transaction means a group of steps that must all succeed or all roll back together, and a transaction lives on one thread. Async, by definition, starts a new thread, so MuleSoft's documentation is explicit. When running inside a transaction, the async scope still runs on another thread. It stays asynchronous. And the consequence, any error produced inside an async scope does not cause a rollback. Think about what that means. Your main flow commits successfully, an error happened inside the async block, and nothing rolls back and nobody is told. If the work inside async must be part of your transaction, async is the wrong component. Full stop. Naming. On the screen the scope is called async name here, a placeholder that was never filled in. 6 months from now, someone opens this flow and sees a box called async name here with several components inside it, and has no idea what it's for. So, don't leave the default async, and don't leave a placeholder. Do name it for the work it does in the background. Send confirmation email, or write audit log, or notify warehouse. A good rule for async specifically: start the name with a verb, because async always wraps an action you're firing off and forgetting. Good practice. Use async for work the caller doesn't need to wait for, writing audit logs, sending notification emails, pushing events to a monitoring system. Always put your own error handling inside the async block, because errors will not reach the main flow's error handler. And keep it short. One clear job. Bad practice. Putting anything inside async whose result you need afterwards, relying on a variable set inside it, using it inside a transaction and expecting a rollback, and wrapping a huge chunk of business logic in it, because when something fails in there, it fails silently and you won't know until someone notices missing data. When not to use it. If you need the result, don't use async, just call the component normally. If it must be part of a transaction, use a try scope inside your transaction instead. If you're using async purely to make the flow faster over a collection, that's the wrong tool. Parallel for each is designed for that, and we cover it in a later module. And if you need the work to survive a crash or a redeploy, async gives you no guarantee at all. Use batch or a real message queue like VM or JMS. Async is fire and forget. If forgetting is not acceptable, don't use it. How many async scopes should a flow have? Practically, 1 or 2. Async is for the side jobs, the things that hang off your main work, and most flows only have one or two of those. If you find yourself with 4 or 5 async scopes in a single flow, that's a signal. You're not doing background work anymore. You're building a parallel pipeline by hand, and you're doing it with a component that gives you no error visibility and no guarantees. At that point, either restructure into one async containing a flow reference to a properly named subflow, or move to batch if it's really a volume problem. And a warning about threads. Every async scope competes for the same runtime thread pools. 10 asyncs firing per request will starve your main flows, and the symptom is horrible. Your API gets slower under load for no visible reason. Let's make it concrete. An order comes in over HTTP. You must save the order to the database and return a confirmation to the customer fast. You also want to email them a receipt and write an audit record, and neither of those should make the customer wait. So, the listener receives the order, you save it to the database. That's the critical path, and it must happen before you respond. Then an async scope wrapped around the email and the audit write, and then the response goes back to the customer immediately. While the email and audit are still running, the customer sees a fast response, and if the email server is down, the order is still saved and the customer still got their confirmation. But here's the trap. If the audit write fails inside that async, nobody finds out. So put a logger, or better an error handler, inside the async block, so a failure is at least recorded somewhere you can see. The questions interviewers ask about async. 1. You set a variable inside async and read it after the scope. What do you get? Nothing, it's not there. Async works on a copy. 2. An error is thrown inside async. Does the main flow fail? No. It carries on and the error never reaches the main error handler. 3. Inside a transaction, does async join the transaction? No. It still runs on its own thread, and an error inside it will not roll back. 4. Does the main flow wait for async to finish? No, that's the entire purpose. 5. Is max concurrency mandatory? No, it's optional and it must be an integer. 6. How do you handle errors inside async? Put an error handler inside the scope, nothing escapes it. And 7. What's the difference between async and parallel for each? Async fires one block and forgets it. Parallel for each splits a collection, runs the items concurrently, and waits for them all. To recap, async runs its contents on a separate thread and the main flow does not wait. It works on a copy of the event, so payload and variable changes inside never come back out. Errors inside it never reach the main flow, so handle them in there. In a transaction it still runs asynchronously and will not roll back. Both sayings are optional, and max concurrency must be an integer. Name it with a verb describing the background job. Next module, flow, subflow, and private flow. What actually separates them and when to use each.